All right, so let's talk about Java, which I didn't get to do last time. Um, so Java is classified as follows, and it's again Java is probably very similar to other languages you see here. So some things that most computer languages have in common are the following. You have either the type or the level of languages. Okay, we have what's called a high level and a low level language. Okay, so in this case, Java is a high level. Um, it is a strongly typed language. The opposite of that would be a loosely typed, or sometimes it's called a weakly typed. Okay, and then it's a general purpose. I mean, you can use it to do a lot of stuff, right? Just not just one thing, but you can do a lot of things. You can use it to write a computer game. You can use it to write, control an airplane. Write control remote control. So used for many purposes, and then also it is case sensitive. Okay, this is a very important issue that sometimes you will run into, which is good because it keeps things in nicely, I guess, in a certain pattern, certain fashion. Because if it's not case sensitive, that means that you have to be extra careful because, and not only that, it actually kind of limits out the number of, say, functions or variable names you want to use. Identifies, right? Because if I use, age with the all lowercase as a name, and then if I use it with a all uppercase, they will still be the same if it's not case sensitive. And that is true for languages like Java and no, I mean not Java. I mean PHP and Visual Basic. Those are not case sensitive, so you have some limitations there. So Java is case sensitive throughout. Okay, from your code to all the built-in functions and so on. Versus PHP is kind of semi because PHP is not case sensitive, but some built-in functions are global variables are actually case sensitive. So you kind of have to kind of know what those differences are. And this is a picture I usually show my students, how to put a certain language in which category, so they kind of coincide with other languages you can see here. So kind of just like a Punnett square here. So you have a low level and then a high level. So anything in this column here, these two boxes will be low level. Anything on the right, two boxes will be high level. And then you have two rows. One is very specific, one is for general purpose. Okay. So and then we have a purple box in here that kind of show you that anything in this purple box is a loosely typed language. And outside of that purple box is a strongly typed. Again, strongly typed and loosely typed means, it just means that for a strongly typed, you have to specify the data type for that variable when you use it. Okay, so if you want, let's just say the name, a variable called age to be an integer type, then you have to declare that with that data type before you can use it. Otherwise, it will throw an error. Whereas in PHP, you don't have to specify that. You just say age is equal to 5, and it would know that that's an integer. And then later on, you can change age to something else because age is now ABC. Now age is now a string. So it's a loosely typed versus a strongly typed. If you declare a variable called age as integer, then it will remain integer throughout the rest of the program. You can't change it. Well, you can, but not to a permanent type. Okay, we'll do that something's called the type conversion, which is covered I think at the end of the chapter 2. We'll go a little bit, but then for now, so you can see that some of these languages you might have heard of them, some you may have not heard of them at all, right? And I couldn't figure out one of them in this upper left category because I don't know one. If you do know one, let me know. It's a very specific purpose, low level or loosely for strongly typed language. I couldn't think of one. I'm sure there is one out there. I just don't know it. But on the bottom left, you'll see that there's one that I used to work with way back in the mid-90s, and it's called the assembly language. This is a very low-level language. When we say low-level, meaning that the code is so close to the machine code, which is binary, zeros and ones, that you don't need a compiler to compile the code. It will just run right on the machine itself because it can talk almost directly, instantly to the machine. Okay, that's a low-level language. Okay. We say low mean as close to machine code as possible. High mean as close to human readable as possible. Okay, so you see one there listed in the assembly language. If you want to see what assembly language code looks like, you can Google for it. You can see some of the example codes. It's very it's still like a little bit human readable, but the process of adding two numbers, you can see it takes a couple lines. Whereas you can do in the high level, just say, you know, total is equal to A plus B, right? You can't do that in assembly. You have to move one number to a register, and then move to a different register, and then you apply the addition, and then you move back to the other register, and so on. So you take about almost 10 lines just to perform a very simple addition operation. Okay, so it takes a lot of work, but then when you compile it, it's really fast because it's so close to machine language, right? So you have both advantage and disadvantages. But nowadays, I don't think we have any. I don't want to say I don't have any, but we still have some assembly language programmers. But I don't think you will be able to find them around anywhere, anytime, because it's very obsolete now. Okay. So if you look on the bright side, on the right side, you see that all the languages now is like shifted all the way to the high level, because it's easier for us to read, right? We can see things better. Imagine you write, so when you write your language or your program in Java, actually what you have, you see that it looks almost like English language, right? Something is equal to something, looks like the math, but then some languages, like even Visual Basic, you see that it's using almost a complete sentence in a language. If A equals B, then, do this, else do that. So it's just like reading a text. So the high-level language are those languages that are easier for us to see. It's almost written in. I'm kind of surprised. I always ask this to my colleagues and other friends. It's like every language you see nowadays, it's always written in English. Imagine if it's written in Chinese, or French, or other languages. I mean, that would be. You're not just learning English, you also learn that language itself too, how to type and use it, right? So much harder. So we're just very lucky it's written in English. Even if, let's say, a language program is created in Europe, in Russia, or in China, it will still be written in English. So I'm kind of wonder how that's done. But of course, English is still the main language of the world. So, all right. So we have things like, for example, Visual Basic. It's a general purpose. It's a strongly typed. Okay. It's strongly typed because you have to specify the data type, whereas PHP, JavaScript, and Python, these are loosely typed. So when you declare a variable, you don't have to specify the data type. You just use it right away. And here's some very high level, but also very specific, like HTML, right? It's high level, but it's very specific only for web development, web pages. Same thing with CSS. And some of the other ones are like Mathematica and Lisp and Prolog. You heard of this before? Okay, these two here are usually used for writing code for AI, machines only, right? Kind of like similar with the VDH, is the VHDL? Yeah, kind of like that. Okay, so these are very, very specific, but they're all high level. And then if you, so down here I've been said that you have different generations as well. We had the first generation, second, and now we're moving to the third generation. Okay, the first generation is usually like assembly language, those very, very old machine language. Second is like the high-level language. That's what you see here. All of these are, second generation, and then we have the third generation is like, you just drag and drop. There's no coding involved. Very little coding. So you can see it's becoming easier and easier. And here's an example of what a high-level language, and it's a third generation might look like. You just basically drag and drop, fit into the little puzzle, and it works. Okay, so we are moving towards that now. And this is an example from our code. If you have not used our code, we'll be holding that here at Gateway every year for the kids to come in and do the code programming. So that's the different generations. And then we have, of course, the procedural type and object-oriented type of languages, right? And this example here is Java. So Java is a pure object-oriented programming language. object-oriented always has classes. That's why in Java, the first program in Java, every program in Java had to have a class. You cannot have a Java program without a class. Okay, that is just the fact. So that is the difference between a procedural and object. And then the strongly and weakly type here, it just means that, for example, you have data types. You have to specify the data type, like the int. You have to specify the data type for it to be integer, or is it a string, or is it a double, or a Boolean. Your function also has to have a data type return. This sum or return of a sum of a plus b, but this a plus b, the result has to be a double type. And we'll talk about what double is. And again here, so these two variables here also are double type. Then this function here will return a true or false. It's a Boolean type. So if a is equal to b, then it's true, otherwise it's false, right? So these are data type for variable names as well as functions. Okay, a weakly type will be something like this. This is an example in PHP. Notice I do not have to specify what type this is. A variable called name can store my name. And then somewhere down the code, I change that to a different value. Now it's an integer from there on. Okay, and then later on I want to change it to true, and now it's a Boolean. So you can see that it changes all the time. You can change. And this can get really tricky because you say, hey, if you have if this code is like embedded somewhere in the 100 lines of code, you don't know what it is. You might say, hey, the name says Christian. How come it says true down here? So it could be confusing sometimes. And the function here again, it does not return any. I didn't specify what type of data because I can return 3 different types depending on a certain condition. You cannot do this with Java. Okay, if Java says this function returns a integer, then the return type has to be integer, right? You have to match it. Okay, so that's the difference between a loosely typed and a strongly typed language. Okay, so let's go with data types. So data types is the type of data and also the size of data that you need the computer to allocate in memory to store a certain value. Okay, so there's a special type called constant. Notice just the word constant. Also, you can hear you might hear the term literal constant. Okay, it's a literal string or literal a number. That is the actual number or the characters or the word you use in your code, like the number 45, right? That is a number. It's a constant. It does not have a name associated with it. You cannot reuse the number again. Okay, it's used only once in your code. And if you go to the next line, if you use 45 again, well, that's a different constant already. It's not the same one. Okay, so that's a constant. This is a string constant, and this is a Boolean constant. It's a keyword as well, but it's a constant. You cannot use it. You cannot use a variable for that. And so constants are sometimes good, sometimes not. So in your code, usually you will try to avoid using any constants in your code. Always try to use variables, because with a variable you can change the value anytime. Okay, you can reuse that number again and again. And let's just say if you have a lot of, a name of that variable, the same variable in your code. Let's say you have 1,000 lines of code, and you want to change the number. Let's just say age to 45 or to 63. Imagine you have to go and find all those 45 or 63 and change it throughout your code. Right? It's going to be a lot of work. Whereas if you use a variable name, then you just basically change age up there, and then everywhere else it changes automatically. Okay, so it's much better that way. Okay, so instead of the constant, you will use what's called a variable. Okay, a variable is a string, or it's a name that we use. We meaning human use, because we can understand it better. All it is like a pointer that points to a location in memory. Okay, so it's a memory location that would allow us to store a data type, either an integer or a Boolean value, or whatever that value is. Okay, so a variable is, again, variable means it varies. That's why it's called a variable. The data can be changed. Okay, and the actual name of the variable would be called an identifier, right? So in this case, name is a variable. The name is actually the identifier is the name of that variable name. Okay, so here's another picture to show you how these are stored in memory. So we have the age as a variable name, type short. Again, short means it means it allocates 2 bytes of data. So that's why each row here is a byte. And then in memory, it would have the content here, and you have the memory address at this particular number. I mean, imagine you write something like this. So in assembly language or in machine language, you will have to write something like this using binary numbers to allocate a memory location. That's why it's so much harder this way than to write age. We can see that better, we understand it better, and we can memorize it better, right? So, but there is something you have to pay for that, because now going from age to machine code, we have to translate everything back to machine code. So when you go that way, it takes a lot of costs a lot of overheads, and that's why it's much slower than writing something right on the machine itself, like assembly language. Assembly, you will be writing something like in this neighborhood, right? So it directly affects the computer, but here you have to convert back to binary, so that takes a lot of effort. So the higher up you go, the easier for us to understand, but it takes more effort to compile and run the code into machine language. Okay, so that's the cost of having a high-level language. Then we have the primitive and we have the reference data types, 2 types. A primitive will be something that is a type that is stored what's called a simple data. A very simple meaning just like a number or a name or character. Okay, it's called very simple data. And a reference type is usually like an array, a list, a collection of data is a reference type. An object is a reference type, because object, you will see later on, has a lot of properties associated with that object, right? So an object can have many data types because it can have many properties. Array can have many types of a lot of data within itself. It doesn't store only one data. It stores a collection of them. So these are called references, and reference means they actually point to a memory location. So again, we'll deal with this later. We'll visit this later on. But for now, let's focus on the primitive data type, and there are 8 of them in Java. So we have 6 of them are numeric data types, and 1 for a character type, and we have 1 Boolean. Okay. Actually, we have the string too, but that string in Java is actually counted as a reference type. It's an object. Okay, so this table here is from the book. It shows you the 8 different types of primitive data types: a byte, a short, int, long, float, double, and char, a character, or a Boolean. And the data type will be how you code it is you put it right in front of the actual identifier or the name of the variable name. Okay, so if you want your variable name to be of type byte, then it can only store up to that many character or number in the byte, in a byte long, right? A short will be a short integer, and so on. So different numbers, different data types stores different sizes in your numbers. So down here is from a different textbook. Your book also shows it in chapter, I think towards like the middle or the end of the chapter. It shows you the size of the number you can assign to a variable name. So if you have a variable called num, and if you assign the num to be a type byte, then it can only store numbers up to this many. If it holds 129, then it will crash because that's beyond the 1 byte. Okay, that's how many you can store. If you store as a short, then you can go up to this many in your number. You can only store up to 32,767. If you go 768, it will crash because it's more than what it can hold. Okay, so sometimes you will see that in your code, in your program, you will rarely see a byte in a short because you might run into the issue where you run out of memory size. Okay, so typically you see a int, a long, or a double. Okay, double, as you can see, it's pretty huge, right? 64-bit, it could go that long. 32 is half of that, and then for the float, and then the integer is about the same as the float, except this integer and the float. What's the difference between the float and integer? A float is another name for real numbers. What's the difference between the two? A float and decimal, right? Okay, remember the integer does not have decimal numbers, right? If you do have a decimal number in your code, and if you assign it to an integer, it will truncate the decimal out. It will not keep the decimal. Okay, but in terms of sizes, yes, you can store the same number of except without the decimal. And then you have a double. Okay, so you might wonder, why don't I just use double and then instead of integer and float, or float here, right? Float is 32, double is 64, and they're both, the same, right? It has decimal values. Why don't I just make everything double? Well, you can. It's fine, except that if you only store a really tiny number, after like 100, why would you want to keep double? Because it's going to consume that much memory space. Okay, as soon as you say double age or something, or salary, then automatically it knows that it's going to occupy 64-bit and the memory in your RAM. And imagine if you have 1,000 of double types. It's going to accumulate all those data in RAM, and if you don't use them, well, it's still going to preserve those memory spaces, and eventually you run out of memory, right? So that's why you kind of be careful. Okay, if this number is not going to get any longer than 64-bit, then I'm going to use it as a long or a float. Keep it that. So it's much smaller. Okay. Okay. So these are the numeric data types, and they're all numbers. Okay. And then we have the string and the character. A character is one byte, one character itself. Okay, so now declaring variables. We have done this already. If you have, not sure, have you done this in chapter 1? I don't remember. I think you just probably use the system out.print. Yeah, okay. So when you want to declare a variable, we call it variable declaration, you would do like the following. You have to specify a data type because it is a strongly typed language. If you don't specify it, if you do this in, like, say, in Notepad++, it's not going to throw any error until you run it. It will tell you the error. But if you do this in IDE, like in Eclipse, it will tell you right away. You have to include the data type, okay? And then followed by the name of that variable name, and which is the ID, which is identifier. And identifiers are unique. You cannot have the same identifier twice in your code. And you have the optional assignment operator. Assignment is the the equal sign. And then you have the ending semicolon, right? So it will look something like this. Int my age, and then you terminate that semicolon. So these four here are 4 different data types. I did not assign any values to them. Okay, so for example, in this case, number 3, I didn't apply number 3 because I didn't put the equal sign. But once you declare these variables or those data type, then from there on, those variables have to have those type of data. You cannot suddenly change your mind down later and say, hey, I want my age to be double. You can't. Okay, you have to go back to your code and change the code again, and then rerun your program, or maybe recode it, everything else. And once you declare them, you don't have to specify the value. Then after that, you can go ahead and then assign the values. we assign the values, your initial values, we call it initialization. Okay, you initialize your value, your variables, by specifying a data type, a data to those variables. Okay. Or you can do it all at once, following those 4 steps, including the equal sign, and then do it all in one time. So int my age is equal to 24. Okay, and then double salary is equal to 50,000. And as a rule, if you're not familiar, you cannot put commas in here. Okay, you can't. It will say that's an error. So no commas, no special characters. You can, because it's a double, you can put number, you can put a decimal if it's like 50,000 and 45 cents. You can do that. Okay. And then we have strings and Boolean and so on. Notice I have 4 lines. You can do it separately. Each line is a statement. And each statement you terminate with a semicolon. And if you want to combine all of them into a single line like this, that's fine too. The only thing is you would separate each of those with a comma, right? Comma. And then they have their own data type. They have their own identifier. And they have their own value. And then you would terminate that single line at the end. As you can see, yeah, it saved me 3 lines, but then it's really hard to read, right? Of course, the computer doesn't care. It's fine to the computer, but if it were to you or to another programmer, and they want to go back and look at the code and try to fix it, it's going to take a while to locate what these data are and what they hold. Okay, you can do that. You can also do this. If you, let's say my age, my ID, and my favorite number are all the same of type integer, then you can combine them together that way as well. So you don't have to say int my age, int my ID, int my favorite number. You can combine all together in one line and then separate each of those with a comma. And if you have some values assigned to it, you can also do this, assign the value. Okay. And I want to add one more line. If you don't, you should be able to do as well. You could say my ID, I don't have a value. You can leave that out, it's fine. Okay. So my ID has no value, but the other 2 do. And then later on, you can assign my ID with a value. You have all these different options. But again, do this sparingly because I would not recommend this. I know it's much shorter, but it's hard to debug and to look at your code and trace later on. And if you do it this way, it's much easier because you can then put comments in there. You can say, this is for, what's the purpose of this variable? It's for used for what? This is used for what? So you can document your code better this way, okay? Whereas in this, it's kind of hard to tell. Okay, so variable holds one value at a time. And this from the book on page 61 kind of show you that if x is 2, y is 10, and z is equal to x, if you want to swap those digits of those numbers, you would have to do some kind of trick. And this is a very common situation where you would swap 2 numbers. Okay, if you want to swap x and y, how would you do it? Right? If you don't do it this way, how would you do it x and y? X is 2, y is 10. If you want to swap those 2 numbers, well, you can't. You cannot just say, oh, I want to put x is 10, or x is y. If x is y, then 2 is gone. You lose that value, right? So you have to have a third variable to hold one of those numbers so you can copy it back. So it takes 3 steps to do that. This is a what I call a swap. You swap the 2 numbers. It's a common. Actually, it was a problem way back in the old days when computer scientists want to figure out how they can swap these 2 numbers without losing the actual value. Okay, so you need a third one to store, and then you can swap this way. So put x into z temporarily, and you can swap the x is y and the y is z, so z is now 2, so x is now 2, and so you can swap that this way. And you will toss out z later. Okay. I just show you that because simple data type can only store one value, and that's why it's much harder to swap it that way. Okay. Now the next one is the named constant. The keyword is the named constant, not just constant. Constant is just a number or a little constant. But with the named constant, we're talking about a constant value, a fixed value that is assigned to a particular identifier, right? So here, if you look at this, the pi is the identifier, is the variable name, and by convention, constants, named constants are always capitalized, all caps, with the underscore if you have multiple words. Okay. In this case, it's pi. Pi will be assigned a value of 3.14259, and it's of type double. Okay, you need decimal, and then the keyword is final. It's final, meaning you cannot change it anymore. Once you assign this number 3.14259 to pi, and you are done. You can't change it anymore when you run the code. Okay, so that's why they use the keyword final. And other languages, you might use a different keyword. Like, for example, in Visual Basic, they use the keyword const as a constant. And languages have different keywords, but Java uses final. So everywhere you see final, it's always a constant variable. Like, for example, you have number of departments is 20. That's of integer type. Pi or text rate. And so the question is, when do you use this? Okay, you use it when a value of any type, whether it's a name or a number that is going to stay fixed throughout your program. Like, for example, what? A text rate, right? Usually a text rate will stay constant. The initials of a state, Wisconsin, will stay WI constant. So you can use those as constant, or even a company name, like they use here. Okay, so that way you can easily reference it in your code. And you can use it if it's math. You can use it if it's number. You can use it in your math operations. Okay. The only thing is, again, once you define a constant variable, you cannot change the code later on. So here, if I say pi is this, 4, then later on I cannot change back to a different number. That will be illegal, and when you run it, it's going to say it's a constant number. You cannot change it. Okay. So operators, the two special operators are the equal sign and the plus. Okay, the equal sign is used as an assignment operator. Again, meaning you assign a value to a variable. It's not an equivalent sign. It doesn't mean A is equal to 12. It's not a comparison. You assign a value to the number. And again, different languages might use a different operator. Some might use like the colon to assign values. But typically the equal sign is pretty common as an assignment. Okay. The plus is used as an addition, also as what's called a concatenator. Okay. Concatenator is a special character that allows multiple strings to combine together. So in Java, I use the plus sign. JavaScript also uses a plus sign. Now, like PHP, we use the dot instead. So different ones, and Visual Basic use the ampersand sign. So you have different type of characters, but in Java, you use those. Only thing is that you might have a conflict, and you run into an issue, which might give you a logic error, right? So, for example, if you use A and B, if A and B are integers or numbers, then it will perform an addition operation. But if A and B are strings, then they will concatenate those two strings together. Okay, it will combine the string together. Like here, if your string 1 and 2 has these two words, then you can combine the hello world together using the plus and the code. And so now string 3 will equal hello world without spaces, because we didn't supply any spaces between. We'll combine those characters together into one long string. You can do that in this operation, or you can also print out in your statement in the system out this way. So you say the program says, and then you put the single double quote ended there. You plus concatenate the first string, which is hello, plus and then a space. You give it a space, and then plus the string 2 and plus the exclamation mark to give you this hello world. If you don't include this piece here, then what you get is you say hello world like that, right? So little pieces like that is important sometimes. Okay, it makes a whole difference. So that's a concatenator. Also, it's an addition symbol in the mathematics. If you have any questions, please let me know. Okay. Once I'm done with this lecture here, we'll come back from break and we'll do some examples in the code. Okay. So these are the different types of numeric operators. Pretty straightforward here. It's kind of tiny at the bottom here. It's a percent sign. That is what's called a modulus in other languages. Okay, what that means is that it will give you the remainder of the result, what that result is. So in this case, in this case you have like 20 divided by 3, or we call it 20 mod 3, you will get a remainder of 2. So it will return the remainder and not the actual number. A division will be, of course, you get the value out of that. If you divide two numbers, and if those numbers are integer, then you will not get the decimal part, right? We'll do some example later. The augmented assignment operators, these are augmented, meaning there's like shortcut. Okay, so usually we'll say if I is a number, it's a data type of integer. If I is equal to I itself plus 8, okay, and you can shorten that by saying I plus equals 8. Okay, so you can rewrite that to shorten your code. Same thing with the minus and multiplication, division, and then of course the modulus as well. So you have all those shortcuts. You'll see that these are very common in most programming codes. Usually they'll use that way. If you're adding the number to itself, okay, only if you add it to itself. If you don't, it doesn't work. Okay, to make sure that you have to add to itself. If you notice, you add a to I itself, and then we assign a new value to itself. So in terms of operation, it's always coming from the right to the left, right? You know that, right? Okay. The operations occurs here first. So it would, if the I is 5, then 5 plus 8, and then if this is 5, well, now it's no longer 5. It's going to be 13 now. So you would do this side first, and then assign it to the left. It's always from from right to left. Okay, in terms of math operations here. Okay, so those are pretty common. Not just Java. You see this in the PHP, JavaScript, C, C++. All these are on there. Then we have these increment and decrement operators. These are again another shortcut for adding 1 to itself or minus 1 from itself. Okay, so you have a variable called j. And then you have a variable called I, and then I, if you want to increase I by 1, then you can put the plus in front of I or behind I, like this, right? Like this or like that. And there is a difference to, I'm not sure if those of you who are C programmers or C++ programmers, what's the difference between the plus in front and plus behind the variable name? Anybody know? Okay, so Yeah, the increment and decrement. Do you know what the difference between put it in the front and put it in the back? Or your result, you still get the same. As you can see, it's still 2.
In the front, you increment it before you do the operation, and if it's 9, then you do it after the operation, right? Like the summer, for example, if you're summing them, you increment it, then sum it, as opposed to if the pluses are after the I, you could sum and then increment one, or maybe multiplication, summing would be the same result, but is that
Yeah, I think right. I think you kind of get there right. Right. It does increment in both cases. It will increment I to the next number. Okay. Only thing is there is a difference is that right. So plus in front of the I means if I is in this case I is 1, right? Then before I hit the enter key, and before you run, because you run this code, it's gonna run, and then before it moves to the next line. Then then the I will become the next number, which is 2. Before you hit the enter key, I'll show what that later on, but that's what it means. It means before it moves to the next line, the number will increment first. Okay, before it jumps to the next line, and then what the after means the I will not change until after the code, the line here moves, or actually the command or the head of the pointer moves to the next line. Then this will increment to 2. Okay, it's like, so it's so as you run the code from line, it points this way. Okay, it points to this line here. Before I move to the next line, I gets incremented, and then it moves to the next line. Here means if I is 2, when I reach here, I is still 2. After I run it to the next line, now I changes to 2. Okay, it depends when you move the head of the code here. It's kind of hard to see it, to think about it, but you see the code, you see it easier. I'll try to show this maybe next time or someday. But there is a difference between the two. Okay. Same thing here, minus and front and after. So this is a shortcut. So the plus I and I plus is just saying the same as saying I is equal to I plus 1. And then here will be like same as saying I is equal to I minus 1. Instead of having all of that, you just put plus I or minus I. And you only do that to I usually do that to integer values. Okay, you will increment it by a whole number, and only by 1. And you see this a lot in, especially in the loops, for loops. Okay, the relational operators. These are your equivalents: equal or not equal, greater or less than or equal to. Okay, these are pretty straightforward here. This is like math, right? Less than, greater, equal to. These are your math symbols, but we don't write this in the code because you don't have these kind of symbols. We'll write it in this way in Java. Okay, these are the equivalencies to these here. Notice the equal in math, you use equal sign. In Java, if you want to equate two numbers or two operands, you will use two equal signs together. Okay, if you use a single equal sign, then it's an assignment operator, and you will have some unexpected results if you do that. So it's like here, radius is equal to 1 or to 0. Use the two equal signs. These are Boolean operators. Boolean operators will always give you a true or false. Okay, so the first is a not. The exclamation mark is a not, meaning you would change you would negate a statement. If the answer is true, then if you put a not in front of it, it will mean now it's false. You will force it to be the opposite of what it is. Okay. The double ampersand here is an and conjunction, and then the or will be the two pipe symbols together, meaning that the left one operator is true or the other one is true, then you're good. With the and means both have to be true, otherwise it's false, right? And then the exclusive or. Again, we'll do some of these examples when we come back. And then I think finally want to talk about is this scanner class here. Notice again in chapter 1 you did a lot of the outputting to the screen. you know, and this is where you want to read the input value from the user, from the keyboard, or from usually from the keyboard or another device, but maybe from a mouse or something like that, right? So typically it's a keyboard. So what you want to do is you need to import a class called scanner class, which is a subclass of a utility util, which is a subclass on Java. So as you can see, it's java.util.scanner in this fashion. A dot means it's a separate class, and this is a child class of another class of another class. It's very common, okay? And Java is like the parent class of all classes. So you see that it's always java.something. So you import that first at the very top of your program, and then in the inside the command or the function main method, you can instantiate an object called new scanner, and then you assign a variable called input, and then from there on afterwards you can use the input to read the data. So this is an example from the book. So here in the program, you have the import on the very top. You need to include that library or that class. If you don't, then you cannot use this keyword scanner in the class here, and it will generate an error. Okay, so you will see that as we progress, you will see that you'll be adding a lot of classes at the top. You'll be importing different types of classes. If you did the example in the book about the dialog, okay, remember you have to import another class to allow the J option pane to display, right? Same thing here. So once you import that class, then you can now create a variable out of that, and you will use the keyword new followed by the same class name as here, the data type, okay, another word for data type, and then you use a system.in inside this parentheses. Then after this, you can use this as a variable to read the input. So as you'll see in this line here, name is equal to input device, which is this variable here, dot next line. Means it's waiting for the next line to be read in. So as you execute this line, this program is going to start from here, top to bottom, 1, 2, 3, 4, 5. When it reaches this line name, it's going to wait. It's waiting on the screen for an input. So it won't proceed until it receives some type of input from the user. So if you type in a number or something, hit enter, and then it will move on to the next lines. And then now you have the name has a variable, has a value or whatever that is. So it's a name, and then you can see that when you print it out, so you add another input with the age, and then finally you say your name is, and then again use the concatenator plus name. If it's John, then we'll say John, and you are, the age would be 24 years old. Okay, so this is for reading input from the user. You will be using this a lot as you read inputs. The book also shows you a different method of how you read it from not just the console, which is what they call the black screen, but also from a prompt, a window, pop-up window, which is, again, you can use the J option pane to do that for you. So that's the scanner class, and you can have different types. You can read different types from the input. I also want to put a note down here that all data read in from the keyboard always come in the form of string characters, even if you put a number. If you ask for age, then if you don't use one of these functions here, then it will read in as a number. It's a character 45. And if you want to use that in a math operation, then you have to convert it to a type of integer. Okay, which leads me to the next, which is the final part here. It's called a type conversion. So everything you're reading input from the keyboard, if it's a number, you always have to convert it to a integer type, or a double, or whatever that is, before you can use it in the calculation. Okay, so you have two types called the implicit and explicit type. The implicit type is that some variables, Java is smart enough to know that you are trying to add a certain type of data to a variable name. So it would imply that, okay, I think you mean you want to use an integer because you give me a 45 or 40 number, right? Whereas if you put a character that it knows that you're expecting a string or character type. Okay, sometimes it doesn't work the way you want. So when that happens, you have to use what's called an explicit type conversion. That means you have to do it this way. This is an example of a explicit type. Okay, so notice that the bank balance is a type double, but this new variable here called weekly budget is the type float. Because they're a different type. If you remember the chart, float is much smaller than double, right? Double is way down here. It's about 64-bit. Float is only 32, which is half of that. So technically, you cannot put a large bucket into a small bucket. It will crash. And so if you want to make that work, then you have to change the result here, which is a double, and I want to force it to be of type float so that it can fit into this bucket, which is of type float. Okay? So when you do that, then you actually truncating some data out of that whole result so that it will fit into this float. But you can't do that. So by doing that, you can now force this result to fit into a float type by putting this float typecast in front of that operation. And you put that inside a parentheses around it in front of that result. Okay. So here is example again. So you have a float, which is much larger than an integer, and you can truncate the float and make it small. Force this result to be only type int, so that means it will drop all the decimal numbers, and then and make it fit into a int type. Okay. Okay, so that's that. And the reference types are, we'll probably do this later on, but I want to just briefly reference here. You have three major types. The string. Notice the string is a special type in Java, and it uses a special character, the capital S in string. Okay, and then because it's a class, special class, and then we have the arrays and we have objects. And again, this will be covered in the future chapters. So for now, these are the main types of reference data types. And what that means is that you can actually hold more than one value. Not only that, it has some properties that you can actually associate with these objects or these types of data. So, and this is special objects types, especially array. And you will see that you can see how that can be a problem sometimes if you're not careful with arrays, because the reference meaning they point to a memory location. So if you alter two arrays, A and B, and they point to the same place, if you alter one of them, then you also alter the other because they're referencing the same place. Okay, so we'll get to these later. All right, and these are just some functions that are associated with the reference type, but I just put it here so you can see what they are. We'll deal with these later. All right, are there any questions about these notes here? If not, then we'll take a break, and then we'll come back and we'll continue on. But you have a question? You wanna?
When what you were explaining about the data being truncated, like if the double is turning into an integer, does it round to the decimal?
The double turn integer? Yeah, I think it will round to the next largest integer value. Okay.
It doesn't round down, or
No, it does. You know, when you convert, it's different than if you just say force a value to an integer. It's a great question. We'll see how that is used in the code when we come back. How's that? I believe it does either round out, round up or down. It doesn't really care. It will ignore it. it may not even round up or down. Like for example, 3.14, it would just, if I had to convert that into a integer, it would just toss out everything on the right side. It would not round up or down. Yeah, if it's like 3.925, it would still just keep 3. Okay. But we'll see how that works. I believe that's how it works, but we'll see. Okay, we'll take a 10-minute break. We'll come back about 6:40, and then we'll do some examples.